Hello, and welcome to a video which is going to be about normal distribution. Now, this is a topic that's going to be around for quite a while, almost till the very end of this course. Now, I am going to be very picky and very specific with how you show things, because for what we're going to be getting into in a few lessons, you're going to have to do more than just what's presented here. And when you start doing more, I just want to make sure everything is in a very organized manner so everything can be found easy, and no matter who does this, it's going to be all in the same place for everyone. Now, what you are going to need before we begin is I do have a file with, I believe it's 8 of these, 6 or 8. This is called a standard normal curve. And you're also going to need this, which is called the z-score normal distribution table, where you should see a picture of that normal curve at the top as well. Now, do use this table. Your book might have a table of its own, but I want you to use this one because some tables are read a little bit differently than others. Now, for a standard normal curve, they always have in the middle, this is the mean. And for standard normal curves, using z-scores, this is z equaling 0, where z is a z-score. A z-score is a way to easily interpret data that might have different labels. It's sort of like you're making things that have different labels of unit to them all into one generic label that you can easily compare. Now what I want to do here is I want to find the area under this curve between z equaling 0 and z equaling 1.03. Now what you're going to need to do is any and all z-scores you're given, put them, label them on your picture. So in the middle is always z equaling 0, or your mean. Because in the future, you're just going to be told the mean is like 52.3. Well, you'd have 52.3 right here, but then you would end up changing that to a z-score, and that's to come in a future lesson. Now, for z equaling 1.03, if this is 0, that means 1.03 would have to be to the right, because this is sort of like a number line. You have 0 here, so anything to the left is a negative z-score, anything to the right would be a positive z-score. So I'll just put it right here. And yeah, I sort of said that without care because it does not matter, really. All that matters is you have these z-scores in what would be their appropriate places. So when you see a positive z-score, it's somewhere to the right. So this will be 1.03. Now what it asks for is it wants the area between these, which is this part right here. And you see me drawing a double arrow? I want you to do the exact same thing. Draw a double arrow from 0 all the way to 1.03 inside the picture. Now to find that area, that's where the z-score table comes from. So you have 1.03. All of the numbers inside this table are from 0 to that z-score on the outsides. So we have 1.03. So I would have to go down here to 1.0 and then come over to the 0.03, which is 1.03. Now, it's probably going to help you to print this table out. You're going to be using it a lot. And I have seen a lot of people use rulers for this because all these numbers are very close together. It can be easy for your eyes to just jump at one other column or row, and using an actual ruler can help minimize those silly mistakes. So inside the table we have 0.3485. So that's going to go inside the picture. 0.3485. And that happens to be the answer to what's being asked. The area between 0 and 1.03 is 0.3485. Now z-scores are always going to be 2 decimals, except for a couple instances, which are at the very bottom of this table. There are 2 z-scores that exist, 1.645, 2.575. Those are the only scenarios where the z-score has a third decimal place. Every other time, if you're finding a z-score, it's always going to be rounded to the second decimal place. And these have their own area values. So to recap what was done, I put 0, put 1.03 in a mark for it, drew a double arrow from 0 to that z-score. Then I looked up 1.03 on the table. So 1.0, and this is 1.03, and got 0.3485, which is inside the table, so it goes inside the picture. 1.03 is outside, so it's outside of the picture. And between 0 and 1.03, that is your result. Every single value inside of that table is always from 0 to that z-score. And that's one reason why I'm asking you to draw this double arrow, so you can easily see, okay, from 0 to here, it's this much. Now I want between 0 and negative 1.26. So I have 0. Negative means to the left, so somewhere over here. And that will be negative 1.26. And I will need a double arrow to show that I'm representing the area between. So I need to look up negative 1.26. But there's a subtle problem, which is out on the outside, these are all positives. But that's okay. This standard normal curve is symmetric. Whatever you have on the right, you have the same thing on the left, and vice versa. Which means whatever area this is right here would be the exact same if you had from 0 to positive 1.26. So what you do is you just look up 1.26 as positive. So I go to 1.2, scroll all the way over to 0.06, and it gives me 0.3962. So the area would be 0.3962 here. The area between 0 and there is just that amount, so 0.3962. Okay, so now let's do the next one. This just says to the left of 1.24. So I'm going to need to put 0 here in the middle. 1.24 would be somewhere to the right. Double arrows always from 0 to the z-score. Always from 0 to the z-score. And what I need to look up is 1.24 on my picture, or I'm sorry, on my table. So 1.2, go over to 0.04, which is 1.24, so it's 0.3925. Now this said it wants to the left of this, which means it's wanting all of this. All this part here, and all of this right here. But all we have is from 0 to there. Well, this 0 mark splits this picture in two. Well, if you split something in two, that means on each part you have 1/2. So everything on this side is just 1/2. So to go to the left, it's everything that would be in the blue part, which means you're going to have 0.5 plus 0.3925. So it's 0.8925 would be the area. Now, why did I add there? I added because that's what was necessary to figure this out. Try not to get hung up on, because you're going to start seeing some, you're going to start seeing some of these where sometimes I'm adding, sometimes I'm subtracting, sometimes I just look up a number and that's the answer. Don't get hung up on when to do which of those three. Just look at this, put the numbers down for your z-score, make your marks, look up in the table, draw the double arrows from 0 to the z-score always, write that area above that double arrow, and then look at the picture to determine, okay, what do I have to do with the numbers that are inside this picture? Or what direction or directions is this wanting? And that is to tell you, okay, yeah, I would have to actually add or subtract, or there is my result. Here, it wants everything to the left. That means to the left period. So from 1.24 all the way to the left. So it includes the 1/2 plus this part here. Now I want to the right of 2.26. So I have 0. 2.26 is somewhere to the right. Double arrow. And now I can look up 2.26. So 2.26, so here's 2.2. Go all the way over to 0.06, and it looks like 0.4881. So inside here, 0.4881 is the area from 0 to here. Now what's it asking for? It's asking to the right of this, so it wants only this part. So what do we got to do to figure out that? Well, everything on one whole side of 0 is 1/2. So from here onwards, this is all 0.5. But I know this part's 4881. So how do you figure out what's left? Well, say this was just 0.4. Make it easier mental math-wise. If this was 0.4, how much is this? Well, that'd be 0.1, which I got by saying, okay, 0.5 minus 0.4 gives you 0.1. Well, you're going to do the same thing. It's just a little bit higher on the computation skill. So I'm going to take 0.5 minus 0.4881. Now this means I will have to borrow. And if you have to take 0.5 minus something, what's going to happen is you're going to end up with it looking like this, doing subtraction the long way. And you literally will only, for this lesson, be either adding or subtracting decimals. That's it. You will not be doing anything else. But it would end up looking like this. So if you have to end up taking 0.5 minus something, you can just, and sometimes you might see me write down 0.499 and then a 10, which means I had 0.5, but I did the borrowing and wrote in the numbers. Either scenario, you're going to get the same result. So that'd be a 9, 1, 1, 0. So it's 0.0119. Now I want between 0.26 and 1.25. Okay. And let me use some color coordination here. So that one is going to be that color. This one's that color. So put one mark, and it'd have to be 0.26, and then I'd have to put another mark somewhere down here, and that would be 1.25. So I need a double arrow. So I'll need right there, but then I'll also need another double arrow for the 1.25. So I'm going to have to look up both of these individually. First I'll look up 0.26. So 0.2, go over to 6, and that looks like it gives you 0.1026. And then look up 1.25. So 1.2, go over to 5, and that's 0.3944. And again, I want you to do it this same way. If you don't have different colors, that's fine, but you'd need two double arrows here, both starting at 0, going to each individual z-score. Now what it's asking is it wants what's between those. So what it wants is this part. Well, let's make this a little bit easier mental math again. Let's say this color here is just 0.4. This here is 0.1. And it wants this part right here. Well, if from 0 to here is 0.4, but this part's 0.1, well, how much more would you have to go? You went 0.1, but you need to go to 0.4. Well, you'd have to go 0.3. And I got that by doing subtraction. So that's what you'll do here with these. You're going to take the 0.3944, and you're going to subtract the 0.1026. Do some borrowing. 14 minus 6 is going to give you 8. I can subtract, subtract, subtract. So your end result would be 0.2918. Again, don't try and get hung up on looking for a pattern of when you're supposed to subtract and looking at what the z-scores are. Just go with the picture and look at the picture as in, you know, this little bit of 1026, you know, this big bit, there's some overlapping happening and some missing part. That means you're going to be doing subtraction. Now I want between negative 1.20, so that's somewhere on the left, and 1.05, which would be somewhere on the right. Well, I need double arrow for each of these. This one here, double arrow. So I first need to look up 1.20. So I go to 1.2 and 0, so 0.3849. Then I need to look up 1.05. So 1.0, go over to 5, and it looks like 0.3531. And a while back, you might have heard me say in a video, chunk the numbers, and this is really why, because you're going to be dealing with a ton of 3-4 digit decimals, and it's easier to remember 0.3531 than 0.3531. And it keeps you from having to go back and forth to the table over and over again if you chunk the numbers. Trust me, it works, it helps. Now what this is wanting is what's between them. So it wants all of this stuff. So you're starting at here, you're going to here. That means I'm going to have to add these two. So 0.3849 plus 0.3531. And just do the math. So carry where you have to carry. So it would be 0.7380. Now I will give a important info for you, which is this. If I ever add, I should not get a number that's 1 point something. And the end result of this should never be negative either, because it's an area. And everything under here, this is half on one side, half on the other side. So that means you have the number 1 as total. That's why you cannot exceed 1. It can never be negative because negative areas do not exist. Now I said area slash probability because now I want the probability that z is less than negative 1.51. It's the same thing. Just put symbolically instead of using words. So I have 0 in the middle. Negative 1.51 is somewhere on the left side. Double arrow. Look up 1.51. Oh, this would be negative. So 1.51, 43, 45. And it says less than that, which means it wants to the left of that z-score. So this part. So what do you got to do to figure out this part? You know everything on one side is a half. You know this part, but you want this little leftover tail. You're going to have to subtract. And I did 0.5, but I've already done all the borrowing, which would look like this. Then subtract top to bottom. So it's 0.0655. And what I'm doing here is I'm trying to show you how the wording of some of these and the probability notation are one in the same. There is no difference in what's going on between those, and also give you some examples of how to look up on the table, and then hopefully you're being able to look at the picture and visualize, okay, I have to subtract these numbers, add them, or there's my result. So now I want the probability that z is between, because the z is between 0.24 and 2.25. So this guy will be in black, so 0.24, and I'll put it right here. 2.25. Make a big mark here. Why do I make a big mark? Because I'm going to need a bigger arrow, and I don't want to overlap what's happening with the 0.24. Give yourself space to be able to write inside here and make it legible. So 0.24. So 0.2, go over to 4, so you have 0.0948. And then I need to look up 2.25. So 2.2, go over to 5, and you get 0.4878. And it's looking for what's between those. So between here and here is this part right there. And if I want this part here, I know the whole part. I know some or most of it. That means I'd have to subtract. So 0.4878 minus 0.0948. So 0, 3, have to borrow. 9, 3, so 0.393. Yeah, I didn't say 0.3930. If you were to give me this, that's okay. I understand that a trailing zero can be dropped from these. I'm not going to make a big deal out of one way or the other on this. And yes, there are a ton of examples in this video. So I want the probability that z is less than negative 1.75, which is saying I want the area to the left of negative 1.75. So here's negative 1.75, 0, double arrow, and this tells me where that area I'm going to want is located, which is to the left, because less than means left. So look up 1.75, so 1.7, go over to 5, and it looks like that gives you 0.4599. So 0.4599. So I want to have this direction in this area, but I know this much. Now everything to one side again is 0.5. So I'm going to have to take 0.5 minus what I found. So that's a 1, 0, 4, 0. So 0.0401 would be the end result. Now I want the probability of z greater than negative 1.02. So I know I'm going to need negative 1.02, and that's on the left because it's a negative. And since it says z bigger than this, that tells me automatically it's going to be wanting all of this area. So look up 1.02 on the z table. So 1.0 over to 2, 3461. And all of this is colored in, which is 0.5. So I'm going to take 0.3461, add it to 0.5, and that's pretty okay mental math. So you get 0.8461 as the end result. Now I want to work backwards some. I'm giving you the area and I want to find the z-score. So your area is 0.3907, and remember, from 0 to the z-score is what's inside the table. So I'm looking for what's inside the table closest to 3907. Now this does increase from left to right, top to bottom. So I'm going to be looking for 0.39s first. So here I see some 39s. And it was 3907, which is right here. Now sometimes you might not have it fall exactly on something in this table. You might have something like 0.3906. Well, 3906 would be closer to this number than it would be this number. So you'd still go with 3907. So this z-score, so work outwards, 1.23. So that z-score would equal 1.23. Okay, so now I'm giving you a value of in the tail. Well, what I need is I always need from 0 to the z-score. Well, I have this tail part, but I need this part. What I'm going to have to do is I'm going to have to take a half minus this, because remember, everything from 0 onwards is 1/2. So I have 1/2 without this, and that will tell me how much remains right here. So first take 1/2 minus 0.0037. Do the math. And they gave me 0.4963. Now that's what I'm going to be looking up. I want to find whatever's closest to 0.4963. So let's see what's closest to 0.4963. So I'm at 0.49s. It's right here, 0.4963, which is for 2.68. So this z-score would be 2.68. Now this is saying everything from this z-score all the way is 0.5099. Well, again, first, I'll just extend this so I can draw my double arrow without it going on top of what's colored. I need to figure out this area. from 0 to the z-score? Well, everything from z-score to the right is 0.5099. But I do not want any on the right of 0. So what I need to do is I need to subtract a half, which gives me 0.0099. And that's what I need to look up. This would be inside the picture, so inside the table, 0.0099. Well, there is no 0.0099. So I have to determine, it's between one of these. What's 0.0099 closer to? This one or this one? Now here's the way to think about it mentally without having to go to a calculator. Think of this as just the number 80. This is 120. So what you're being asked is 99 closer to 80 or is 99 closer to 120? To get to 80, that's 19 away. To get to 120, that's 121 away. So it's closer to here, which would be 0.02. So the z-score would equal 0.02, and I left some space because this is to the left of 0, which means this has to be a negative. Okay, so now we have another z-score to the left, so that automatically tells me it's going to be a negative answer. I'm given the tail, which is what you usually call the little part. If you have some shaded part or a portion of the standard normal curve on the ends, those are referred to as tails. So I know the tail is 0.0239, but what I need is I need from 0 to the z-score. This is always 0.5. So I have to start off by taking 0.5 minus 0.0239. Did my borrowing. Subtract. And it gives me 0.4761, which is not your final answer. That just tells you what to look up inside the table because that's inside the picture. So 4761. So here I automatically see 47s. And 4761, it's right there exactly. So 1.98. So 1.98, and it being negative because you're to the left of 0 is your result. Now this says find the z-score to the left of the mean, which tells me automatically this is your mean, 0. It says to the left, so automatically know I have a cutoff right here. Somewhere on the left is my mark. I don't know where, but it's somewhere here on the left. And this says so 96.95% of the area lies to the right. Well, I'll do the same thing I have been, double arrow. Okay. And this said 95% is to the right of the z. So it's starting here, going all the way through to the end of the right tail. Now, I didn't put the percent here because these areas, they are percentages as well. You just move the decimal. So if I move the decimal to the left, 1, 2, that's how you make percents into decimals. So it's saying, hey, this is all 0.9695, but I want this part. Well, I first need to figure out what is the decimal from 0 to the z-score. Well, I'm given 0.9695, but I want to lop off everything to the right of 0, which is a half. So here is 0.4695, which I look up inside the table. So 0.4695, and it's not quite there. It's between these. So what is 0.4695 closer to? 93 or 99? Well, 95 would be 2 away from this value, but it'd be 4 away from this value, which means it's closer to here, which is a z-score. Go to the left is 1.8, go up 7, so 1.87. And it'd be a negative because you're to the left. So left, again, so to the left, need a mark, there's a z, it's going to be a negative, need a double arrow, 0, and it says 82.10% lies to the right of this, okay? So 0.8210 is all of this from all the right and this part right here on the left as well. So I got to do the same thing. 0.8210 minus a half, because what I'm doing is I'm getting rid of everything to the right of 0 area-wise that's in blue. So 0, 1, 2, that'd be a 3. So I have 0.3210, and that's what I have to look up. 0.3210. So 0.3s I'm seeing here, 0.3212, 0.3186. 3210 is definitely closer to this guy, which would be 0.9 to the left and 2 up top, so that'd be 0.922. If you put 0.092, that's fine. If you just put negative 0.92, that's fine too. Trailing zeros, I'm not going to say anything if you drop those off. Leading zeros in front of a decimal, I'm not going to complain if you drop that off either. Now this guy says, again, remember it was to the left, the z-score. Go back a little, it was in the directions. Double arrow, 0, and the z-score, it will be negative because it's to the left of 0. And this says 15.22% lies to the left. Okay. So that means this part here is 0.1522. So a little different, but still the same. Because everything from this direction is 0.5. I do not want this, so I'll still take 1/2 minus that blue area, 0.1522, do the math, and I get 0.3478. But that's not your answer because that's not the z-score. That's what I need to look up in the table. So 34 is 78. So I'm looking for 34s. 34 here, 34 here. 78 would be between these. So think of it as just 61, 85. What's 78 closer to? So 78 minus 61 would give you 17. 85 minus 78 is going to give you 7. It's closer to this 3485. So it would be 1.03. And it is negative because you're to the left of 0. I would suggest for you to go on ahead, print out a ton of that sheet where it says standard normal curves. You're going to be using them. You're going to be using these for a good amount of time in this class. If you have questions, contact me, and we're going to use another table for the next video.